Thank you so much for joining our event. And during the meeting, we had a lot of questions, and me and Carsten, my dear old friend here.
Hello, everybody. Yes, Nils.
Hello to you. Like to take the opportunity to answer these questions. And we have decided, so we can keep it short and effective, to divide it into parts, so we can continuously do this kind of event. And let's get started. Carsten, are you ready?
Yeah, I'm prepared for sure.
Here we go.
Okay.
Is there any discussion about lifetime on safety components? I think it's not sustainable to change components that are working correct. What is your opinion about this, Carsten?
Yeah, I think there are two hearts in me. For sure, this is definitely a topic.
Yeah.
On one side, from my personal view, you can imagine, so why should I, let's say, waste components which are working correctly? But here we have to deal with safety components, and that is much more critical than compared to standard components. So we need to ask ourselves, let's say, an operator must feel safe and he must rely on the components installed. Yeah. And therefore, all of our products has been evaluated during TÜV approval and TÜV process and in the internal processes. And the standard requires to define and to calculate so-called reliability data. And this needs to be done and limited by defining and specifying a so-called emission time. So that means when this mission time exceeds, for example, which is typically 20 years, it's stated in the most relevant standard, like ISO 13849, for example, you can rely that maybe not there's a critical situation, maybe when you exceed this mission time by 1 or several days, for sure not. But nevertheless, we need to understand that there are also physical processes behind. Think about capacitors we have implemented in safety-related circuits,
dry,
for example.
Right?
Yes, they can dry. We have wear out parts, plastic materials. Think about interlocking devices where you have mechanical wear out parts, for example. And all these aspects need to be taken into account during failure mode and effect analysis. So therefore, the emission time has their reason, has to be observed. And if there is an application where, for example, a demand for having a longer mission time, then the recommendation is really to go in touch directly with our experts, and we will try to evaluate if that is realistic and can be, let's say, confirmed from our side.
But as I understand it, there is no discussion about this. It will remain as it is.
There is a discussion, but the discussion is that from the principle, the standard says there's a mission time, and theoretically you need to replace a component after the mission time has been exceeded. Yeah, that's the theoretical, or let's say the on the safe side, let's say.
Okay. Thank you so much. And also, Carsten, this document you're providing from Phoenix, I think it's great, where you can find all this data documented. Yeah, backwards.
That's a collected document where you find all these safety-related characteristics, as we call it, for all safety components from Phoenix Contact in one document. Right?
But do I remember correct, is also the SIL values if you're working with process industries?
Yes, partly. Yes, also this so-called substitute values are also being listed there. It's a different approach, as we know for process industry. They are using some different other characteristics as typically used for machinery, for machine building, but the idea and the approach is very similar. Yeah, so both are included in this document.
Okay, I think we covered this question quite clear now. Moving on, next question. The nice slide you showed about this substantial modification, where can it be found?
This flowchart, as you see that here, it's let's say an agreement which we had here, or which we have here in Germany and some other countries like Austria, for example, or Switzerland, where this countries has a common understanding about what is a substantial modification and when is it not. That is still not harmonized on a European level, let's say. Also the let's say new machine regulation has not adopted this flowchart. Maybe this will be adopted in the guide, which will probably release 1 or 2 years later after the machine regulation. But up to now, this is not part of the directive itself. So I assume that will be clarified in the guide a little bit later.
But if you're interested in having a closer look at this, is there somewhere I could download this chart?
Yes, we can share this. Maybe also at the end, I can provide the link where it can be obtained.
Okay, so we will publish it later. Okay, thank you so much.